Hello and welcome to G Fun Facts Online, the place where we dive deep into the fascinating and sometimes startling truths about our world. I am your host, and today we're talking about something literally undermining our cities, a silent hazard that's causing major urban areas to sink. Yes, you heard that right. Sinking cities. So what exactly is going on? This phenomenon, technically called land subsidence, is like the ground beneath our feet slowly deflating. It's a geohazard, and it's happening for a cocktail of reasons, some natural, some very much man-made. Let's get into the science. One of the biggest culprits? Excessive groundwater extraction. Think of it like this. Our expanding cities are incredibly thirsty, gulping down fresh water for homes and industries. We pump so much water from underground aquifers that the land above starts to compact and sink, kind of like a mattress deflating. It's estimated that this issue could affect a staggering 19% of the global population by 2040. That's huge. Then there's the sheer weight of our urban jungles. All those skyscrapers, roads, and concrete infrastructure press down on the underlying soil. If that soil is soft, like clay, it compresses more easily, leading to subsidence. Imagine stacking too many books on a soft cushion. It's going to squish down. Natural geological processes also play a part. Tectonic movements, seismic activity, and even the natural settling of young, loose soils, especially those found in river deltas, can contribute to land sinking. And it doesn't stop there. When we extract oil and gas from underground reservoirs, that can also cause the land to settle. Even our waste has a role. Large piles of municipal solid waste, basically giant landfills, can exert enough pressure on the ground, especially on weak or marshy soils, to cause localized sinking. Lastly, all that underground construction, tunnels for subways, utilities, you name it, can create voids and mess with the natural balance of the ground, potentially triggering subsidence. Now, while climate change isn't a direct cause of cities sinking, it's a massive exacerbating factor. Rising sea levels are a double whammy for coastal cities already sinking, drastically increasing flood risk. Extreme weather events, which are becoming more common, can also speed up erosion and move sediment around, further destabilizing the ground. So what happens when a city starts to sink? The impacts are widespread and incredibly costly. Infrastructure takes a beating. Cracks appear in roads, bridges, buildings, and essential pipelines, leading to spiraling maintenance and repair bills. Flood risk skyrockets, not just from the sea but also from rivers, especially when you combine sinking land with angrier storms. Some coastal cities are sinking much faster than sea levels are rising, which is a terrifying thought. This increased flooding can lead to serious public health crises. We're talking about the spread of vector-borne diseases like malaria or dengue. Damaged sanitation systems and exposure to chemical sludge or foul gases from compromised landfills can wreak havoc on respiratory and digestive health. And, as often happens, these problems disproportionately affect low-income populations who might be living in the most vulnerable areas. Sinking land can contaminate freshwater sources with seawater, worsen water scarcity, and create serious water inequity. Economically, the damage is counted in billions of dollars annually across the globe. This isn't just a hypothetical problem, it's happening right now. Jakarta in Indonesia is one of the fastest sinking cities globally, so much so that the Indonesian government is actually relocating its capital. Other major Asian cities like Manila in the Philippines, Karachi in Pakistan, Tianjin and Beijing in China, and Bangkok in Thailand are all facing significant subsidence. Over in North America, it's not just coastal cities like New York and New Orleans. Inland cities like Mexico City, Houston, San Antonio, and Austin are also sinking. Houston, in fact, is reported as the fastest sinking large city in the US. And of course, there's the classic example of Venice in Italy, slowly being claimed by the water. Recent satellite data has really pulled back the curtain on the scale of this issue. One study found that a whopping 45% of analyzed urban areas in China are sinking. Another looking at major US cities found that all 28 most populous cities are sinking to some degree. That's a wake-up call. So what can we do? Is it all doom and gloom? Not necessarily. Addressing urban land subsidence requires a massive team effort. Governments, the private sector, scientists, and communities all need to pitch in. The good news is, we have strategies. First up, we need to drastically reduce groundwater extraction. This means strict policies. Cities like Tokyo and Bangkok have shown that if you stop or significantly reduce pumping, you can halt or dramatically slow down subsidence. This involves finding alternative water sources. Think rainwater harvesting, wastewater recycling, and even desalination. And, of course, good old-fashioned water conservation in homes, industries, and agriculture. Improving how we manage our water infrastructure is key. We need real-time data to monitor groundwater levels, land subsidence, and even leaks in our water supply pipes. We can also try to artificially recharge aquifers by injecting surface water or treated wastewater back underground. This needs careful study, but it can help restore groundwater levels. Urban planning needs a major upgrade. We must integrate geohazard risk assessments into how we design and manage our cities. This means identifying high-risk zones and maybe even saying no to new construction there. Building codes need to account for land motion, and new constructions, especially those heavy high-rises, should have deep foundations that reach stable bedrock. Green infrastructure is also a great idea. More green spaces, permeable surfaces like special asphalt that lets water seep through, and artificial wetlands can help natural groundwater recharge and manage stormwater. And for vulnerable areas, we'll need stronger flood defenses like seawalls and better drainage systems. Some places are even looking at dual-purpose infrastructure, like tunnels that can also store floodwater. Technology offers some cool solutions too. Advanced monitoring like INSAR satellite data can accurately track land movement over vast areas, giving us early warnings. There is also a technique called deep soil mixing, where stabilizing agents are injected deep into the ground to reinforce it and prevent subsidence. Critically, we need community engagement. We have to talk to the people most affected, gather their local knowledge, raise awareness about what's happening, and get them involved in finding solutions. Public-private partnerships will be vital to fund the massive infrastructure projects and research needed. And finally, there are adaptive strategies. In some super vulnerable areas, this might mean building on stilts, or even exploring concepts like floating cities. In extreme cases, like Jakarta, planned relocation of critical infrastructure or even entire communities might be the only option. The challenge of sinking cities is serious and demands our urgent and sustained attention. It's a complex problem, a mix of natural forces and our own actions. But viable solutions are within reach. What we need is a proactive, integrated approach, blending scientific understanding with technological innovation, strong policies, and community power. This is essential if we want to ensure our cities are resilient and sustainable, especially as the impacts of climate change continue to unfold. That's all the time we have for today on Fun Facts Online. Thanks for tuning in, and I hope you'll join us next time for more fascinating facts about our world. Stay curious, everyone.